look at application problem. So where you're applying the knowledge of inequalities. So a circuit overloads at 1800 watts of electricity. You plug a microwave oven that uses 1100 watts of electricity into the circuit. So before we do anything, we want to make sure that we understand what's going on in the problem. We want to make a plan, like coming up with the verbal representation of the problems in words. We're going to solve it, and then we're going to check and by looking back at our work. So they gave you a little chart here about the appliances here, but right now we know a couple things. I know that the circuit will overload at 1800 watts. We also know that there is a microwave that is already plugged in at 1100 watts. So those are the two things that we do know. So I'm going to make a note of that. So overloads at 1800 watts. Microwave is 1100. So when it comes to word problems, what I like to do, I like to draw a picture of what's going on. Okay, so I have things going on there, but you could draw a microwave. Okay, all right, here's my microwave, and I know that I also have an additional amount of watts, so I'm just going to call that watts, additional. I don't know what to draw for that, but you can draw a picture if you like. Okay, but we know that it has to be less than 1800 watts because that's the amount of overload. So overload watts. Okay, is at 1800. So I always start off with a picture. Then you can then write an inequality to represent that. So the microwave, the watts of the microwave is 1100 watts. Let me take out the W. Okay, plus additional watts. So I'm going to use, here's another information. I'm going to use let W equals additional watts. So I'm going to call that W because I'm using W. You can use X, you can use whatever you like. And it has to be less than the overload amount, which is 1800. Because if it's 1800, it's going to, that's going to happen right there. Okay, or it just shuts down. All right, so it says A, write and solve an inequality that represents how many watts you can add to the circuit without overloading the circuit. So we have our inequality right here. So we're going to go ahead and solve for that. So 1100 plus W is less than 1800. Okay, so 1100 watts plus additional watts has to be less than 1800 watts. And then when we solve for that, we're going to get W is less than 700 watts. So in words, we would say we can add up to 700 watts without it overloading. Okay, because it's a word problem, please make sure to write complete sentences explaining that. So let's go back to the chart right here. So it says, okay, well, for part B, it says, in addition to the microwave, which of the following appliances can you plug into the circuit at the same time without overloading the circuit? So this happens to me a lot at home because I have a microwave and a toaster oven that is connected to one outlet. So I can't run both of them at the same time because they'll shut off. And that's what it means by overload. So let's take a look. So we know that we have up into 700 watts. So that means we can do a clock radio, a blender is 300. That's less than 700. Hot plate, no, because that would definitely overload because that's additional 1200. Well, that tells me that it will be over the amount that is allowed for that circuit. And then the toaster oven will also overload. Okay, that's exactly like how mine is at home. I can't put the toaster oven and the microwave together. I had to run them one at a time. All right, so we know that it says, in addition to the microwave oven, which of the following appliances can you plug into the circuit at the same time without overloading? So we can plug in the clock, radio, and or the blender. So you can actually plug in both of them at the same time or one or the other, but without still overloading the circuit.